Good morning all. Today we are going to see about laser for measurement of length and velocity. The outcome of this topic or the section, after completion of this section, the students able to understood the laser for measurement of length and velocity. This is a schematic diagram for laser based length measurement. The large coherence light and high output intensity coupled with a low divergence enable the laser find the applicant in the precision length measurements using interferometric techniques. Here the laser beam is split into two parts and they are made to interface after traversing two different paths. One of the beam emerging from the beam splitter is reflected by a fixed reflector and other by cube corner reflector. The two reflected beam interfere to produce either constructive or destructive interference. One of the beam emerging from the beam splitter is reflected by a fixed reflector, other by corner reflector. As the reflecting surface moved, one would get alternatively constructive and destructive interference, which can be detected with help of photodetector. As the reflected surface is moved, one get alternatively constructive or destructive interference, which can be detected with help of photodetector. On a machine tool for the calibration and testing, for testing of machine tool for comparison with standards. Next one is laser measurement on velocity. The principle of this system, the measurement of velocity fluid flow can be performed by scattering a laser beam from the liquid or gas. The laser beam interacts with small particles carried along by the flowing fluid. The particles scattered light is slightly shifted by the Doppler effect. The magnitude of frequency shift is proportional to the velocity of fluid. The measurement of frequency shifted directly gives the flow velocity. Then let us see about the construction of this system. The measurement techniques basically consist of focusing laser light at a point within flowing fluid. The light scattered from the fluid or from the particles entrained within the fluid flow is collected and focused on an optical detector. The signal processing of the detector output yields the magnitude of Doppler frequency shift and hence the velocity of flow. Then working. The approach towards the measurement is called dual beam approach. The light from the continuous laser is splitted into two equal parts by the beam splitter. The light from the continuous laser is splitted into two equal parts by beam splitter. The lens focuses the beam to the same position in the fluid. The place where the two beams crosses in the fluid, they interfere to form fringes consisting of alternate region of high and low intensity. When the particle transfers the fringe pattern, it will scatter the light when passes through the region of high intensity. The scattering will be reduced when the particle is passing through the region's low intensity. The light scattered by the particles in the fluid and arriving at the detector will produce a varying output and frequency which is proportional to the rate at which particle transfers the interference fringes.